we're pretty good at power rule. Now we just got to talk about two other rules. We're going to talk about product and quotient, and we're going to talk about them at the same time. And then we will do practice on delta, and then we will do more practice tomorrow as a circuit. And then hopefully by Friday we are pros. And I kind of want to do a short quiz, but we're not going to do any quiz anytime soon until we perfect it. So we'll see. So the earliest possible quiz is Friday if I see that we're really good. But if I see that we're still struggling, then we'll pass it until next week. Cool? All right, so here we go. And then this is from a textbook, the Demena textbook. It's taking into account how many rules we've done. We don't use a textbook here, so there it is. So just erase that rule 5. So the product rule. All right, guys, focus. So the product rule is first times root of the second plus second times root of the first. That's what this is. U is the first function. V is the second function. First times root of the second plus second times root of the first. When you get to delta, they're going to reverse it. Relax, because there's a plus symbol, it doesn't matter. I prefer that you do it this way, but it doesn't really matter. I used to do a proof. I used to do proof of the product and quotient all the time, but then I realized like 75% of you are just like, I don't know what's going on. So now here's how I do the informal proof to make sure that you know that it works. So I just write a function, and right now we just know power rule, right? So let's go ahead and FOIL this out or multiply this to see what this f of x is, so we can use the power rule. X squared times x cubed, that's x to the what power? 5th. You add the exponents. X squared times 3, that's 3x squared. Chop, what are you doing? Right now I'm just doing algebra. 1 times x cubed, that's x cubed. I don't see any issues right now. 1 times 3, that's 3. Putting them in order, I have f of x equals, let's see, x to the 5th plus x cubed plus 3x squared plus 3. I don't see any issues. I think we're good right now. Are we okay so far? Nothing crazy, right? All right, check it out. The power rule that you guys already know. If I were to take a derivative, f prime of x, what's the derivative of x to the 5th? 5x to the 4th plus what's the derivative of x cubed? What's the derivative of 3x squared? Boom, that's it. And that's my derivative. Are we okay so far? All right, I'm going to use this so-called new rule for product rule because I have a product, something times something, and I'm going to see if I get the same derivative. See? So I underline. So this is like my U. This is like your V. See? So now I'm going to use the rule. So let me change my ink. I'll change it to black. All right. So here we go. I'm going to rewrite it. X squared plus 1, x cubed plus 3. And I'm going to go f prime of x. According to my new rule, it says first. So I'm going to call this my first. So I just rewrite it. X squared plus 1 times the derivative of the second, dv dx. So I'm just going to take the derivative of x cubed plus 3. What's the derivative of that? 3x squared. That's it. That's all it says. Plus second. So the second is my x cubed plus 3, or that the v there, times derivative of the first. What's the derivative of x squared plus 1? So supposedly this right here is the same as this. Supposedly. Let's see if it is. We just got to do a little bit of algebra. So let's see. 3x to the 4th plus 3x squared plus 2x to the 4th plus 6x. Combine like terms. 3 plus 2, that is 5. 5x to the 4th. And then the 2, let's see. I already did that. I already did those two. Then plus 3x squared plus 6x. Did I get the same thing? Yeah. Check it out. We got the same. It does not. But I know. Look. You probably will not be getting product rule for something like this. So what's the point of all this? You'll probably be using it for something like cosine x times tan x or something like that. And on those, you'll probably, on those, that's where you'll be using it. So it's just a rule, just like anything else, or cosine x times 3x squared. That's probably would have been a better one. 3x squared cosine x. But anyways, let me erase that because I don't want you to think that's part of the notes. We haven't done derivative of trigs yet. Cool or not cool? All right, so all we're doing is practicing with product rule. So let's look at example 9. Man, when I turned this into a PDF, they really did a lot of competition. Like they really stretched my little equations here. All right, let y equals uv be the product of the functions u and v, and then y prime of 2 equals. So these are just numeric answers for values of for the original function and for the derivative. So it says, what does it says? Dang, it doesn't even ask a question. It should have said find y prime of 2. Yeah, it didn't even ask a question. Find y prime of 2. Well, y is equal to uv, so I'm going to use product rule. Here we go, guys. Y prime of x, or you know what? We don't have to include the x's. We can just say y prime. Y prime equals, they're all with respect to x. First, u times root of the second, v prime, plus the second, v, times root of the first, u prime. Have I confused anyone? All I did was the product rule. First times root of the second, plus second times root of the first. And that's a product, u times v. And I'm going to go y prime of 2 is equal to u of 2. What was u of 2? 3. Times v prime of 2, 2. Plus v of 2, 1. Times u prime of 2, -4. All I'm doing is a product rule, guys. First times root of the second, plus second times root of the first, and just plugging in numbers. 6 minus 4, so I got 2. Y prime of 2 is equal to 2. How do we feel? Nothing crazy, right? Tell me, Kunduru. All right. Don't worry. We'll do some more. All right. There it is. That's the product rule. Now we just got to practice it. And don't worry. We'll do a lot of practice. Now we're going to go right into the quotient rule. Anytime you're dividing, check it out, guys. All right, guys. Anytime you're dividing, you're going to use the quotient rule. Here's the quotient rule. Bottom times the root of the top minus top times the root of the bottom over bottom squared. If you go to YouTube, they have a little song. Do you want to hear the song? It goes low D high minus high D low over low low. Yeah. The top is high, the bottom is low. Right? High and low. Low D high, when you say the D, that means derivative. Low D high minus high D low over low low. Yeah, say it with me. Ready? You always start from the bottom. Started from the bottom, now we hear. So you start from the bottom. Low D high minus high D low over low low. So what does that mean? Bottom, low, D high, derivative of the top, minus hot top, times derivative of the bottom over bottom squared. See? So you always start from the bottom. You started from, like Drake says, you started from the bottom, now you're here. So you always start from the bottom. So here we go. Let's test it. This is like U. This is like V. L squared. F prime of X. Bottom, so low D high, low, X squared plus 1. D high, the derivative of X squared minus 1. What's the derivative of X squared minus 1? 2x, so put 2x, minus high D low, so x squared minus 1 times derivative of the bottom. What's the derivative of x squared plus 1? 2x over low low, x squared plus 1 squared. There it is. That's quotient rule. Now you're just doing algebra. We just did the calculus. Calculus was just following the rule. And now you don't seem impressed. You're like, oh. No. And now we're just doing algebra, guys. Let's see. 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus quotient squared, so catch up to there. I distributed the negative, in case you're wondering. Minus 2x cubed plus 2x. I distributed this negative. Don't forget about that negative. Don't forget. All right. So finally, my derivative, the 2x cubes cancel out. 2x plus 2x is 4x. And there it is. That's my derivative, doing quotient rule. Low D high minus high D low over low low. Yeah. I don't know. It's some random person. All right. Here we go. You guys ready? No. Oh, x squared plus 1, that's already with the square. That's the simplest as you can get. All right. Relax. I want a tangent line. Do you want to use it? Do you want to use the quotient rule or do you want to use the power rule? We can use the power rule. It doesn't matter. You'll get the same answer. Example 11. It's a quotient. You can use the quotient rule, but you could also use the power rule if you do some algebra. Yes, we did it in our circuits. X squared. Oh, look, I haven't taken a derivative yet, guys. You can use the power rule, see? So one of those x's cancel out, and you get you get x over 2 plus 3 halves x to the negative 1. Yeah, I'm about to use the power rule. So you could do that. And then check it out. Y prime equals 1 half minus 3 over 2x squared. And remember, when you subtract 1 from the exponent, that's negative 2, and negative 2 means it goes down. X squared, your laws of exponents. And then if you want your slope at 1, y prime at 1 equals, there's no x there. And that one, you just substitute the 1 in there. So 1 half minus 3 halves, that's negative 2 over 2. So negative 1. Don't worry, we're going to do it again. Are we okay so far?
Wait, what were you doing again?
I just did power rule. I did algebra first, right? Okay, so let's say you don't want to do power rule and you just want to do the new rule that you just learned, quotient rule. So I see it. It's a quotient. I'm dividing by something. And you can go, yeah, low D high. So y prime equals low D high minus high D low. So the derivative of 2x is just 2 over low low. So 2x squared. It looks more complicated. It's not that bad though. I'm going to go y prime of 1 because I want to know what my slope is at 1. So let's see. If I plug in a 1 in for x, if I plug in a 1 in for there, x equals 1, x equals 1, you get 2 times 2, which is 4. Minus, let's see, 1 squared is 1, 1 plus 3 is 4, and 4 times 2 is 8. Do you guys see what I did there? Over, okay, I'll wait. All I'm doing is plugging in x equals 1, guys. All I'm doing is plugging in x equals 1. 1 squared is 1, 1 plus 3 is 4, 4 times 2 is 8. 2 times 1 is 2, and what's 2 squared? 4. Look what you get. Negative 4 over 4, which is just, are they the same? It does not matter how you do it. As long as your logic is correct, you will be fine. Slope at x equals 1. Oh, don't go to the next page yet, guys. We haven't found the tangent line. It literally says find the equation of the tangent line. We just found the slope of the tangent line. Point slope form. In case you don't know point slope form, y minus y1 equals slope x minus x1. So here we go, guys. There's my point. Y minus 2 equals slope, -1, parenthesis, x minus 1. If we were AP testing, I would tell you to leave it alone right there, but we're not there yet, not even remotely close. So I'm just going to leave it in slope-intercept form. So y minus 2 equals -x plus 1, plus 2 plus 2, y equals -x plus 3. This is the tangent. I like to see what I'm looking at to see if this really. So do you see that link? I should probably do this in advance. I'm gonna click on it if it lets me. Yeah, it did. It lets me. All right, let's see. Let's see what. Don't worry, I'll go back to it, guys. What is the equation that they gave me again? The original. Y equals. What did I have in the top? All right, guys, focus. X squared. X squared plus 3. Guys. What happened about? All right, here's how x squared plus 3 over 2x looks like. Let's type in the tangent line. Well, first let's type in the point. 1, 2. So there's my point. Do you guys see that point? All right, let's see let's see how my tangent line looks. It better go through that point. All right, focus, Kondura. Focus, guys. What is my tangent line? Guys. What's your tangent line? And there it is. Look at that. It looks beautiful. Cool or not cool? Okay. All right, here we go. Let's go to the next one. Okay, now we're ready. All right. You can always take more than one derivative. You can take 2, you can take 3, you can take 4. It does mean something in real life, but right now let's just talk about the notation. So check it out. So here it is. So here you can see the notation d dx. I'm taking the derivative of dy dx. So this is the notation for second derivative. See? This is the notation. Look at this. Y prime prime prime. That's the derivative of the second derivative. And this is the notation for third derivative. Why what? Why so many what? Because you can keep taking derivatives. Yeah, like what's the rate of change of a position time graph? Velocity, right? And then what's the rate of change of a velocity time graph? Acceleration. So the notation for any nth derivative, so let me go ahead and write it here. Did I not put it in here? I thought I put it in there. Dang, I didn't put it in there. Okay, any nth derivative where nth is an integer. Nth is an integer, a number. Will always look like this. D to the power n, y, and then dx to the power n. And I know the dy is supposed to really be like the difference in y over the difference in x. We're talking about infinitesimals. So this is very similar to delta y over delta x. Later on, we're going to call them differentials when we get there. But this is saying, and I know that some of you guys are thinking like, shouldn't it be like that, the dx? It is, but in math, this is the notation that we use. It's just known for the nth derivative. So if I tell you what's the fifth derivative, you would write d5y over dx to the fifth equals, and that means fifth derivative. Does that make sense? Okay. All right, here we go. It says find the first 4 derivatives of this function. Relax, we're going to go slow. Y prime, I'm just using power rule. What's the derivative of that function, guys? 3x squared minus 10x. Is that it? Yes. I'm going to take the second derivative, y, and I'm going to put 2 primes on it. You could also use this notation up here, d squared y over dx squared. What's the second derivative of that? Perfect. Third derivative, I'm going to put y, I'm going to put 3 primes. Fourth derivative. Yeah. Sometimes they use Roman numerals. All right, guys. Sometimes they use a number in parentheses. It just depends. If you go into a physics class, they might use little dots. So if you see like y and you see 2 dots or 2 dots in front of the y or on top of the dot, that means second derivative. It just depends what class you're in. So don't freak out when you go to UT Austin or Trinity and you see, oh, what is this, Chav? I've never seen this before. They're using dots. It just means derivative. Instead of little hyphens, they put little dots. Are we okay? All right. Here we go, guys. Focus, focus. This is the last question, and then we're just going to do a whole bunch of practice. All right. It wants me to take the derivative of this. You guys ready? I'm going to put equals. I'm just using my rules. First times derivative of the second plus second derivative of the first. All I did was use my rules. Are we still okay? They tell me that these are the values that x equals 0, so those are the values I'm going to put in. So here we go. Equals u of 0 is 5. V prime of 0 is 2. Plus v of 0 is negative 1. U prime of 0 is negative 3. So all that is, let's see, 5 times 2 is 10. Negative times a negative is a positive, plus 3. So all that is 13. Are we okay? All right, let's go to letter B. What rule am I using? Quotient. Bottom, low D high. Bottom times derivative of the top, u prime, minus top, u, times derivative of the bottom, low D high minus high D low, all over low, v squared. You always start at the bottom, because that's where Drake started. He started at the bottom, now he's here. Are we okay? Okay, here we go. V of 0. V of 0 is negative 1. U prime of 0 is negative 3. Minus u of 0, 5. V prime of 0, 2. All over v squared, 2 squared. All right, let's see what that is. I'll write it up here. What happened? Oh, yeah, it is. Yeah, I was just following whatever you guys told me. Here we go. 3 minus 10 over 1. So it looks like it is negative 7. Cool or not cool? Okay. Be careful. They try and trick you here. They're trying to. They just switched the V and the U. Don't worry, guys. We're almost done. Bottom, or I like to say bottom times derivative of the top minus top times derivative of the bottom, but if you like to say the little song low D high minus high D low, that's fine. So low D high, U, V prime, low D high minus high D low, V U prime, all over low, U squared. You see what we did? All right, let's see what this is. U of 0 is 5. V prime of 0, 2. Minus V of 0, negative 1. U prime of 0. All over U squared, which is 5 squared. Okay, let's see what that is. 5 times 2 is 10. Negative 1 times negative 3 is 3, but it's 10 minus 3. So 10 minus 3 is 7 over 25. Nothing crazy, guys. What do you think, Ro? Are we doing okay? Okay. All right, here we go. Last one. All I'm doing is taking a derivative. So that 7 is just a constant. Leave it alone because it's a product of 7 and V. So this is just 7 v prime minus 2u prime. All right. 7 times what is v prime? 2 minus 2 times what is u prime? Negative 3. 7 times 2 is 14. 2 times 3 is 6. Well, negative times the negative is a positive. And it looks like we got 20. What happened? Ask.
What is that? I missed something.
I just took a derivative. Yes, espera.
Why did you use the
Oh, because I'll write it right here as a side step. If I took the derivative of v with respect to x, that's just v prime. And so, and I just have a number in the front. Like, you could use product rule if you wanted to. Like, maybe you're thinking, like, why didn't you use product rule? You could, but remember, 7's a constant. So look what would have happened if I would use product rule. Don't write this down, just listen. First times root of the second, plus second times root of the first. See? And then when you see like that time, that's just going to zero out, and you just get 7v prime. So you just leave the 7 alone and then just put a prime on whatever variable you have. You know what I mean? Ask me questions, guys. Ask me some more.
I don't know.
What's up?
I don't know what's a quotient or how to set up the.
Well, first it needs to be something divided by something. That's quotient. And then whatever's in the top, you're going to call that your high or your top value. Whatever's in the bottom is your bottom value. And then you just use the quotient rule. Bottom times root of the top. This guy right here. This is bottom times root of the top minus top times root of the bottom over bottom squared. Because they use different letters for the top and bottom. They use U for the top, V for the bottom, and then this one they use V for the top, U for the bottom. Ask me more. I just take you just go 7V prime minus 2U prime.
I don't get it.
What do you mean?
I don't know. I don't know what I don't get.
Well, it tells me to take a derivative. So the derivative of 7V is 7V prime. And the derivative of 2U is 2U prime. The derivative of V with respect to x is V prime. If you're trying to think, guys, if you're trying to think like, why don't you use the product rule? Like, you can't. You'll just get 7V prime. Like, you can if you wanted to, but you're just making life harder. Yeah.
In my head, I was like,
Yeah, you're not taking the derivative of V with respect to V. We're not there yet. All right, guys, we're done. Do some practice on delta. I don't think I've pushed the button to make it go live. I'll do that right now. So take a 2-minute break.